Thank you for coming. For those who don't know, my name is Steve Sheets. I am the director of MoDevAcademy. That's the Modev DC's new academy that will be doing training both at the conferences as well as seminars. I'm a long-time Macintosh and iOS programmer. Founded a company called Where2 with my former partner from AOL days. And the two of us do consulting as well as training like this. So we're available for consulting if anyone wants to talk with us afterwards. Modev DC, we kind of identified there was a need for this. There were two areas. One is new developers who had never developed before, but also developers who have developed before for iOS and wanted to learn more, because the iOS and Objective-C, as you're going to learn shortly, is an incredibly rich environment. There's an old 20-80 rule. You only use 20% of the features of any piece of software, and it's really true with Xcode, really true with Objective-C. Use that 80% of the time. And hopefully we're going to expand your knowledge here today. Our seminars are going to happen January 22nd, 23rd, 24th. This is the only URL, other than the one I'm going to give you shortly, that you should pay attention to. It's the MoDevAcademy. MoDevAcademy at gomodev.cd. That one, this week, will have the registration up online if you want to take a look at it. I don't know the prices have been set, but we're somewhere in the $3.95 a day price, which for this level of class is actually rather inexpensive. Now, as I mentioned earlier, I do not like to have you guys write my URLs down and have me delay my slides. So all the URLs I'm going to give you today, and some from the other sessions, are going to be at this address, gomodev.com, MoDevAcademy resources. Write that down. You haven't done it before. Okay, let's talk about Objective-C. We're going to talk about what is Objective-C. We're not going to do the timeline, I'll skip that. Things to know about Objective-C, the syntax, and briefly about the frameworks. Objective-C is the language for both Macintosh and iOS devices. iPad, iPad mini, iPhone. We now have 3 different flavors of iPhone. The traditional iPhone, Retina display iPhone, and the 4-inch iPhone. Objective-C is a high-level language. It is a subset of ANSI-C. It fully supports C11, which is the 2011 standard. Fully supports all C++. Though C++ and Objective-C is completely different from the objects. It's a language, a runtime environment. It has a object-oriented structure where objects are subclassed off of NSObject. NSObject is the base subclass for almost everything. I'll talk about that shortly. Foundation class. Foundation class is one of the first SDK frameworks that you have to learn. Foundation class is like C++ standard objects. It's the class of things to handle arrays, data structures, time elements, everything you think of as traditional programming nowadays of set objects, it handles for you. And it's also memory management, and we're going to go in a little detail about memory management and the improvements. It's one of the newest areas of Objective-C. There was Objective-C 1.0, Objective-C 2.0, Objective-C 2.x, and now what's being called modern Objective-C, which I hate that name because it's, when they come out with a new version, are we going to have postmodern? Yeah, then avant-garde Objective-C, I just don't understand. What Objective-C is not, it's not a precompiler. People thought that, oh, Objective-C came out and it actually was a precompiler, because that was the day with precompilers. C++ was nothing but a C compiler. No, it's more than that. It's no relation to C++. C++ objects and Objective-C objects are different. You can actually run a variation called Objective-C++, because C++, besides the object, has 2 or 3 really interesting features, like passing by reference. And people like to use that. Fully compatible between them. It's actually based on Smalltalk. It comes all the way back during the 80s. It also, there is no doubt in my mind, so some of the Java guys get upset when I say that someone who was creating Java looked at Objective-C when they were designing it. Because Objective-C implemented certain features no one else did at the time, and then Java changed them to implement these features. So it is a structure that has been changing over time. Okay, it is the same language development for most the Mac OS and the iOS. There are 1 or 2 features that are only Macintosh only because of the increased power of a Macintosh. But there are several books out there that talks about Objective-C, and they're both for both platforms. So take a look at the books, be sure. It also changes, so do not go out and get an Objective-C book that's 5 years old. It's not worth it, doesn't give you any information. Now, foundation classes we mentioned earlier, those are the base classes. Cocoa classes, that's AppKit, that's the Macintosh, you guys won't have to worry about that. The one you're interested in is the Cocoa Touch Kit, the UI kit. Now, foundation class objects all begin with NS. Any idea what NS stands for? Next step. That tells you how long ago it was developed. Next step classes all begin with foundation class, all begins with NS. Cocoa classes all begin with NS, but you guys don't use Cocoa class. Instead, you use the AppKit. They all begin with UI. So if you're ever looking at an iOS program and you see NS, you know that's part of the foundation class. UI, that's part of the AppKit. Now, having said this, there is a real fuzzy line between what is Objective-C and what is foundation class. It was less fuzzy in 1.0 version, but they kept adding really great new features. For example, you can't program Objective-C unless you're using NS objects. NS objects are about foundation class level. Memory management was not in Objective-C, that was part of the foundation class, but now memory management is built into the language. So the lines, when we're talking about this, that's one reason we have to teach this class together. Foundation class and Objective-C is all rolled into one big thing. Okay, keep that in mind. What's that? Oh, thank you. They ran out of glasses, I saw. Other thing to be aware of, it's an extremely active language, constantly being developed. They've been having major updates. I follow computer languages for years. It took 11 years from C99 to C10 to become C11 to come out. No, there was C10 first, then C11. So Apple's changing, like I mentioned it. Because of this, you have to keep up to date. Don't expect to learn what you did here today and never have to go back to Objective-C. The new techniques are often not backward compatible. Apple tries real hard to have it be forward compatible, so the code you call will be able to last for at least a good amount of times. But lots of times new things come out and they're using new techniques or new features of the language and they don't implement that call using the old structure. For example, we've just recently done something called blocks. Blocks are a great replacement for what used to be called callbacks. You said it's a piece of code that says execute this when I'm done with this UI. All the code was updated, so there are now calls to use blocks. The couple new UI calls were only implemented using blocks. They weren't doing the old style. The reason I'm mentioning this to you is that means you have to keep up to date on new techniques. There is also another feature. It's the downside of being so active. Depreciated methods. You will see in your documentation methods that are said depreciated, supported, but depreciated. That means the call's still there, it still works, but Apple's warning you it's going to go away real soon. And if you link to the new SDK instead of the version of that SDK, a lot of times it will tell you that call won't function anymore. So, best I can tell you that you're going to start a process of keeping up to date. Hopefully that's the reason you're making the big bucks or being hired by someone, is for your knowledge. Now, having started that, let's get into some of the details. Objective-C is a header main file metaphor. .h, just like C. .m is the class code file. You have the .h file for your interface and your .m file for your implementation. A couple of the other ones you'll see. XIB is the user interface file. Hopefully Duncan talked a little bit about Interface Builder and I did in my talk. That's the file you create. Now it used to be called .nib. That's the older one. And they have a brand new one called Storyboard, very specific class of user interface, and truthfully has not been widely accepted by developers yet. That's another secret people don't really tell you about. For all of Apple's successes, I can point to 3 failures. Apple comes up with new technology all the time. They have a lot of failures. So don't be surprised that we still have some old stuff. Did I mention Objective-C++? .m is normal C++. If you put .m and m, it suddenly links in all the... Now that's not documented anywhere. If you just change the name to .m and m, suddenly all the C++ files that you need are linked in automatically. No other changes in the project. Now let's start foundation class. Has every standard C class you can think of, has NS integer, that's just an integer, Boolean, CG float, CG point, size, CG rect, everything you would expect. If you see any code that says NS point float or rect, that's Macintosh code. The difference between them is CG float versus NS float was 32-bit versus 64-bit. Apple did the NS integer as a replacement for integer because depending on which rev of the Mac, you were running 32 or 64-bit. But they're pretty much, it's the same usage. Does anyone not understand object-oriented programming? Good, because it's the...
over that?
No, I'm not going to teach polymorphism or inheritance and all the other stuff. Yeah, I can't teach a class on that. But for basic things, instances are objects of members of classes. It's that simple. You instantiate an object by creating an instance of a given class. Has all, if you think of it as object-oriented encapsulation, it does have single inheritance. It does not support multiple inheritances with C, like C++. It's more like Java, and Smalltalk I mentioned earlier. Because of this, we use what's called a protocol to implement what you normally do is multiple inheritance. We'll get to that briefly. Again, design patterns are heavily used by Objective-C. I wasn't sure how many people were here for earlier talks, so I had to release some of this stuff. I got this quote from Apple's website. NS object is the root class of most Objective-C hierarchies. Interface for the runtime environment. It's used by everything and handles allocation, init, copying. The reason why the Apple didn't go to C++, C++ at the time was strictly a pre-compiled macro system. There was no runtime environment. You couldn't see what object you were at runtime. You couldn't check to see what calls. Because Objective-C is based on a runtime environment, you can do these type of things. You can actually say, is this method supported by this object? And that is the main difference between Objective-C and C++. This runtime object linking. I've been using the term methods for describing the functions that are inside of an object. That is the incorrect term. It's the common term, but it's incorrect. It's actually a message. You have your object, you have a procedure, a selector, and you make a message to that object to say, hey, I want to invoke you, and here's the parameters. Which means that at runtime, you can have an object, you can say, hey, do you support this call? Oh, if you don't support it, I'm not going to make it. If you do make a message call to an object that doesn't support it, you get a runtime error. This is an incredibly powerful technique, and it's not something common in C++. It's not that common in Java either, though it can actually be technically done. Like I said, all objects can accept any selector. And code can be determined at runtime if the object can handle that selector. So here's our actual interface. We have here the interface call. That's the new name of the new object. That's the subset of the higher level objects. All objects in Cocoa have to be a sub-object of a parent type. Having said that, no, the Objective-C language actually allows you to have your own base class. If you do that, you have to write your own code to do allocate, init, copy, everything else. No one does that. So everything's a subclass of something. If you want a controller object that's just code, make it a subclass of NS object. Otherwise, you're subclassing something else. Instant variables, fairly familiar with that, and then properties. Excuse me, then methods and properties. We'll get to properties in a few minutes. Here's the implementation. Say implementation, oh, by the way, / is this normal comments if you're not familiar with that. Implementation and the name of the class, and then you add your methods there. It's that simple. Now, it's gotten even simpler. What's that? We'll get to that in a second, okay? Good eye. Wasn't sure you could spot that up there. With the new versions of Objective-C, you do not have to put a method in the interface. So if it's a private method, a private message, you can put it there, and you don't have to put it forward of the one that uses it. It's actually smart enough if you put the method down here, declaration, it knows about it. Now, because of this, there is no way to have private messages that someone can't jump into. If I make a message to your object and you define the method privately and we're sharing code, and I actually make a method call to that object, and you understand that selector, I can do it. This is the way people hack into some of the private SDKs on Apple. I don't recommend doing it. Apple will jerk your application from the store, but it's actually possible. What else was mentioning here? Okay. Now, what happens if you wanted to add calls to an object? You can add your own methods there, but it'd be nice to be able to add calls to objects that are already defined. That's called categories. Since everything is nothing but a message list for methods, you can actually make a call to an object that Apple defined and write code that says, well, when I make this call to it, here's what I want you to do. That's how they handle multiple inheritance. They actually allow you to expand your existing objects for additional calls. It's very common to do it. It's very common to have code that people pass around from one project to another. I found these 5 routines very useful when I'm doing graphics. It expands the existing objects. And that's the basis of a lot of code, is what you're going to be is creating categories. A couple keywords that you should be aware of. Self. I forget what the C++ term for self is, or Java term. It basically means the current object you're inside of. What's that?
This.
Thank you. It can only be called inside a method.
In JavaScript, this all kinds of things.
Well, for Objective-C, we use self. And there's also an ID type. ID type is a kind of a wild card. You can define an object as an ID type, which means it can be any object in the world, and it accepts any selectors in the world without any compiler errors or warnings. Okay, so you'll see that all over the place. You'll get the hang of ID. It's not that difficult.
What's the trade-off to doing an ID?
What's that?
I'm guessing there must be some trade-off, right? Or you could just do ID for everything.
I don't understand the question.
I mean, you said that ID is pretty generic, right?
Yeah, ID is the same thing as saying NS object star, which means a instance of NS object, but it has a very specific use in the sense, if you make a call to an object of that class that the call isn't there, you'll get a warning with your compiler telling you, are you sure you want to do this? If you do it to ID, you won't get an error because it says, oh, you know what you're doing. Okay. Now, I hope you understand what the idea of an instance method is. It's basically object-oriented. Since everything is a message, you don't have abstract object methods. You don't have final methods. You do not have methods that can't be overridden. Everything can be overridden in Objective-C. You don't have to say this call can be overridden. It just occurs normally. That's about the main importance there. Now, what about a type of method that affects the entire class? That's called a class method. It's also called a static method. That's where we got the minus symbol. If you do a plus symbol, that's a static method. That is a class method. That method is called in a different way than an instance of the method, but it doesn't have any variables. It doesn't have any instance variables. This is one thing that Objective-C is a little behind. They didn't have any class variables either. So if you're going to do a class variable, use globals. Now, do some of you understand what I'm doing, or am I, at this point, have I gotten a little too technical for you? Okay. This is mostly used as a design pattern. So you make a call to an object to do things that will affect them all, to give you the currently shared one, to access global data. So let's say I'm keeping a list of all views in the window. And as part of creating the view, it adds itself to the list of some global space. Well, at some point I might want to say, give me the list of all the views I have currently. And that would be a call to a global method. Now here's how we create objects. Creating objects is a two-step process. The first step is allocating the memory for the object, and the acceptance step is setting it to the initial value. The object, test object, that star next to it means that it's a pointer to that object, a object. Oh, unlike C++, there are no static objects, in the sense there are no objects that are done off the stack. Everything is done from memory. Now, allocate actually takes memory aside for your object, and init then fills all the correct variables and such. Now, if you subclass NSObject and you have your own initialization code, you override the init. Some views, some other objects like views and windows and such, they have more fancy init calls where you have to have a parameter list. So every object class in the world has what's called a base init. That's the init that you have to override, and you should check the documentation. So if you were to override that object, you'd have to override that init for that one class. But this is the basic one. So override init if you're going to override NSObject. Otherwise, check it out. If the object is deallocated, and we'll explain in a few minutes how deallocation occurs. If the object's going to be deallocated, you then free up any memory that you allocated in the dealloc call. Dealloc is always called when the object is being disposed of. So everything has an allocation, initialization, and then deallocation. And that's how memory is handled. Any questions so far?
Help me on relative to ARC.
We'll get to ARC in a few minutes, okay?
Okay, but
Well, you can't explain ARC until you explain retain and release, and then we'll get to that, okay? Now, using objects, they use the dereferencing for instant variables. Object, dereference for value. You can use that object value plus 1 is another object's value. And to actually make the call, you get the name of the object and the selector with parameters. Now, when you do a class call, you do the name of the class and the method. So that's the difference how invoking. That's an instance method. This is a class method. You get used to it real fast. Unlike C, we'll get to that in a second. Get to it right now. When you have a list of more than one parameter, you just don't have commas between it. You actually have names between it. So it gives you a description of what's going on. There's a very specific name space that you do. You do the name of the object, first parameter, the name of the next parameter, that parameter, and so on and so forth. And then when you invoke it, the same way. Object this, do something, colon 1 with percentage 0.7. So that's a multi-parameters. There are some calls that might have 12 parameters. But at least with this, you can tell the name. Now, there are a lot of parameters where it says do something with percentage, and another one that says do something with date. So those are two different calls. Now, they're probably related, but keep your eyes out for that. I mentioned that specifically. Calculate value with flag, calculate value with flag with number is two different calls. Okay, scope. Scope means who can use the instant variables. Everything by default is public, private and protected are supported. Honestly, no one uses these. We'll get to why they don't use in a few minutes, but truthfully, these are not very commonly used. The default is protected for an instance variable, which means that its class and the subclass can use the. Now, people got confused about scope, so they came out with accessors and getters as a call, as a method to return instant variables. So that's why this isn't used very much. I know I'm going fast, but there's a lot of material here. Let's say we have a variable that's an instant variable, but it's a private scope. But this variable is something that we should sometimes pass to people. We shouldn't allow them to change it, but we should pass the information. So we have what's called accessors. You have a call that says, hey, return the value. And sometimes you might even have a call that says, hey, set the value. So Apple had the call, name of the value, the name of the instance of the object, and the name of the value inside the brackets. That was made the call. Same with the set. But that got to have very large lines of code because you saw these objects with the brackets everywhere, and it got to be a little confusing. So Apple came up with something called dot notation. Instead of saying this value with brackets on the other side, you just say this dot value. It's exactly the same thing. Now, accessors, setters, and getters are a good way to abstract your program, good way to hide the internal data, and it's heavily used in the iOS environment. You got to understand what you're seeing there is not accessing a variable. You're calling a method, which then may be accessing a variable, but it might be doing something else completely. especially for the setters. A lot of setters actually physically do other things. If you're documenting or if you're reading someone else's documentation and it's a setter and you do something different, you better put it in the documentation. Here's the set value version of it. Again, very specific namespace. It has to begin with set and then the name of the variable with the capital letters for the capital letter for the first word. Set value is the same thing as saying this dot value equals something. Again, you're actually calling a method.
When you make a variable, do you get those accessors for free?
That, what you do with a property, and that's what we're going to get into. You're right. That came out with Objective-C 2.0 as properties to handle this. Now, setters for getters. Oh, this is talking about the namespace. There's very specific rules for names. If you have a method name, it has to begin the first word of the name, lowercase, first letter, and the following words of the name have to be uppercase. And if you do that and you make it a getter, works fine. For the setter, the first word, of course, is get. And then the second word, it was the name, has to be uppercase. So these are very specific rules. What's that?
You mean set.
If you're doing a set, yes, it's, oh, typo, you're right. That should be set, not get. Thank you. Now here's the reason why it's so nice to do it this way. Think of that look one. This one dot dex label set value is equal to that dot list dot text. How many brackets do we have there? It's ridiculous. Well, now we just have, it makes it look like it's fields. It's so much easier to work that way. And you've completely and utterly abstracted the data so you don't know where the data is. I'm not going to go over this. We have a very set naming convention. It's very well documented. Globals should begin with G underscore every letter lowercase. Constants should begin with K underscore every letter uppercase. Class names, the first word should be uppercase, and so on and so forth. This was a convention. Apple recommended it, wasn't enforced. Now with the new version of Objective-C, especially having to do with ARC and properties, it is enforced. So learn how to do it this way. It's surprisingly easy once you get the hang of it, but until then, leave it. Word of advice, there are some things that are not mentioned here. Create your own conventions. If you have properties, begin them with P, the name of the property. If you have local variables, begin them with A and the name of the variable, so that you can look at your code and immediately identify whether or not you're looking at a property, an instance variable, or a local variable. That's a good programming technique no matter what language you work on. Apple has suggestions for this. Have it be the same with whatever group of people you're working with. Now, I mentioned before categories. Categories are a way to expand existing objects, or they're ways to expand the objects that you're creating so that only you know about the call. If I create an object and I have a public.h definition and I give it to you to work with, I don't want you to use the internal methods that only I'm supposed to access, because I want you to be abstracted. I want you to be able to only give the public header. So I can create categories that only I use and give you and you don't have access to the private information. Defines an object already declared and adds code for that method. I'll show you an instance of this. There are actually three types. You can add a public category for an existing class. I have NS view, and I want to add a call that says underline. I add the call, and every NS view gets this call, even NS views that are subclassed by me for other objects. There's also a public category for one that I create a new object. My view is my new object class, and for some reason I want to put it in a separate category. So that I created this class now, here are the calls. Oh, I want to have a 3D version of my view. Here are the calls to handle 3D stuff. You're still only having one object, but two different .m files now. And then there is the third case, where they're not technically called categories, they're called extensions. They're not in the .h file, they're in the .m file. You can actually declare a category there and then say these are new methods, these are new instance variables, which are only known about in the .m file and are not known about by a public header. This is kind of interesting. This allowed you to actually add instance variables to existing classes, but only if you're the one creating the class. Did that come out across right? You can't add instance variables to NSObject. You can add instance variable to myView, even if the instance variable was in a separate file. That's brand new. The only difference between categories and extensions is that you don't have names. Here's the format for category. You say interface, my object, that could be NSView, that could be myView, and then the name of the public category. And if it's an extension, that's blank. This is very new release stuff within the last 6 months. As I said before, here's how you define an instance variable. You put the bracket there and you put the instance variable right there. Again, brand new. The other half of Objective-C that's different than anything else is we define protocols. Protocols are a way of defining a group of calls in the header file, but not the implementation of them. So I say, here's a protocol to provide list data. And any object that needs to do that will then support this protocol. And then I can pass that object around to things that say, I need you to support this protocol. Now before, you actually have two objects that have multiple inheritance. Instead, you have just one object that can support any number of protocols. I'll give you a simple example. Let's say I have a sound engine. And the sound engine can receive calls, and when the sound's done playing, it wants to inform whoever called it, hey, the sound is done. Simple syncing job. So I make a call to the sound object, and I pass myself to it because I support the sound informer protocol. And when the sound is done playing, the sound object says, oh, I better inform this object in a callback method saying sound done. There is tons of uses of this in iOS. This is a very common design pattern, and you have to get used to it and really understand why it's being done this way and the simplicity of doing it this way. Java actually came out with this interface after Objective-C had, so I'm not sure who invented it. Oh, by the way, if you start doing your own protocols, it's a really good idea to pass the object that's invoking the call in the call. That way, if say you have a protocol that supports data source, you can use data sources from more than one thing because you're actually passing the objects as being called. Otherwise, you don't know where the call's coming from. Here's how you declare protocol. Word protocol, my protocol, and then everyone's subclasses is off of NSObject. That's just saying that that object protocol can only be supported by objects of NSObject or below. This is new. We had the required, and we had that word should be optional. Originally, NSObjects were either formal or informal, which means you had to support everything in the protocol or you didn't use the protocol. Now we actually have the call option. And that's a typo, I'm sorry. I should have said option there. That means this object that supports this protocol has to support, must implement, and can implement. And the call that makes this uses that call I mentioned earlier that says, hey, do you implement, can implement? And if you don't, I won't make the call.
Compiler error if you don't have a required protocol method?
This is the reason why they had the optional one. It used to be if you had a protocol and you didn't support that, you would get a compiler error. I think it was actually technically a warning. You'd get a warning at compile time and an error at runtime. With the new optional feature, no, you don't. And if you write your code, the invoking code right, you won't get a runtime error either. Here's how you implement the protocol. Interface, my class. I say, hey, I want to support my protocol. And then you don't include in the .h file the calls themselves because you already know what the protocol is. You do include them. Looking at the wrong page. Yep, this file is incorrect. You do include them in the .m file in the actual implementation. We mentioned formal and private, so I'm going to skip over this right now instead of detail. There are three really main uses of protocols. One is a delicate. This is one of the most important design patterns around. It's the fact that instead of subclassing some object, we said, I'm the controller of you. In which case, the object has to know who is its controller. And instead of saying, oh, you have to be a subclass of this, I say, oh, you have to support this protocol. As the controlling object, I get calls to me from the other objects, and I have to support them. That's the most common in that one. Now, for user interface for views, data source protocol is pretty common. And that instance is saying, hey, instead of you setting variables in the view, when the view needs to display, it calls its data source and says, hey, give me a list of things, or what should I display? This is becoming more and more common as a technique. It's a true implementation of model view controller. It also is nice because then if you have a really complex data structure, you can make calls for specific elements of it. You can't just say, give me the entire object. You can say, hey, give me the information about cell 3 of the tree 4. It's much more efficient. And the fourth use of protocols is an information, an informer. I can say, I want to know this object when it's done, informing when something is done. That sound example I gave a few minutes ago is a good informer call. Now the delegate call, lots of times the thing being controlled makes a call to the delegate saying, hey, what should I do in this instance? And then that's usually a method that has to be implemented. For example, views, view controller, view makes a lot of calls to the view controller to say, did do this. That's an informer call. Other calls that says, can do this. That's a controller call saying, hey, I need to know whether or not I should be doing this. See the slight difference between them. The last thing I'm going to mention is forwarding. If you have an object that's a subclass of another object, or if you have an object that's a field of another object, generally you have to do import. But the import is incredibly inefficient use. It takes a long time on the compiler. So instead, you just define the class other object in your .h file. And then in your .m file is where you have the importer. This improves the compile time, the speed. It also means that if I change the .h file, the compiler not necessarily has to recompile that other file. So I'll get used to doing that. You mentioned properties. This was the implementation of 2.0 that made it so nice. Apple came out with the idea that the vast majority of the code being created was nothing but setter and getter objects. And that was silly because we know what setter and getters are supposed to do. So they said, we're going to create in object-oriented C, a single line way of defining these properties. That say, this is an instant variable, I want to have an accessor and a getter, and then if the user decides to override that and do a custom one, there wouldn't be any problems. And it greatly reduced the amount of code I had to create to do this. Just 1 second, please. Thank you. Here's the typical accessor. I mentioned before, value, set value. In the code, we basically had to say, edit integer value, return, there's that instance variable I mentioned before, set value. I was getting hundreds of lines of code like this in every program. This was identical. And Apple engineers noticed this and said this was a waste of time. Properties. Dot notations are fully supported by properties. You can still override any accessor, the setter or the getter if you want. Most of the times people don't do it. The first version you actually had to define the instance variable still, but the latest versions of property you don't even have to do that. You have a single line of code. Like I said, this is about the third version of properties and they finally got everything right. Here's how you declare it. You say a property, then the class of the property, and the name of the property. Non-atomic, this is probably the only mistake they had. Atomic means all-encompassing. A non-atomic object is not thread safe. An atomic object is thread safe. For some reason, they made default be atomic. Problem is, atomic objects take much, much longer to implement and to execute. So everyone in the world, unless you're writing a thread-safe code, sets non-atomic. That's a field. A read-only property, it says, I only am going to create the accessor. You don't want to have a setter, just a getter. Now we start having properties. Now this is where it really shines. Non-atomic objects, for that, they will handle memory management for you. It will retain and release it automatically, and you didn't have to write any of the code. This was the #1 thing that got rid of memory management calls for a while. Strong and weak, we'll get to that in a second. There is one special type for objects that support copying. If you say copy, when you pass it a string, it doesn't keep a pointer to that string, it actually copies the string, which is a very nice thing to have. Okay, I'll go off. You can see how everything's kind of interlinked. We've been skipping over memory management for a while. Underlying engine, Objective-C is a retain count system. Every time you allocate a memory, that object has a count number. When that count number reaches 0, no one's using it, throw it away. Every time you create it, you get 1. Every time you release it, it goes down by 1. If it reaches 0, it gets released. Now, Apple knows that what you really want to do is have a count of 0 that gets thrown away when you're done with it. So they have something called auto-release. Auto-release says, set this object down by 1. If it reaches 0, puts it in a pool, and when I go back to my main event loop, dispose of it then. Because chances are, if I auto-release it, something else might grab it. This was a major performance over what we had before that, back in the days before. They came out, this was the very beginning. But memory management up into that had to be calls to retain and release. And I'm not exaggerating, 80% of the code was memory bugs. Of all the bugs you got, 80% of it was memory related. I'm mentioning that here. Circular reference, memory leaks, the nil reference, or even worse, if someone released it and you didn't know that, suddenly you're calling an object you think is an object in memory and you're going off. And the worst thing about these type of bugs is where it crashes is not where the problem is. So, now there are still some problems. Circular references, if you remember, that's when one object's referring to another object and it's still not being released. So Apple's tried a lot of solutions. They tried garbage collection. Man, the performance was terrible. It was so bad that it couldn't be implemented in iOS. And even on the Mac, it was terrible. Properties was a good start, but we still had problems. Then Apple found out something. They had been spending so much time making release and retain so fast. They said, well, why shouldn't the language just do it all the time? Every time you access a variable, increase the retain. Every time you don't access it, release it. And that's called ARC. And it's built into the Objective-C language. So you do not have to worry about memory. Now, it's not garbage collection. There's no hit going back to the main event loop. They have a really neat feature called weak. Strong, that means you're referencing the object. Weak, that's a special object. If the retain count goes down to 0 and you're still referencing, that variable gets nilled out. That means you no longer crash by looking at variables that are dereferenced. So this is the new memory model. Does that answer your question about ARC?
Sort of. I guess where my question was is now with ARC, do I have to do any releases of memory management?
Unless you are creating objects yourself that are new classes and you're creating factory methods to do them, there are very specific rules, so you have to follow for the name. But if you're just using general use, no. It's that simple, and I've been using it. I am so happy. By the way, this requires iOS 5. That's the main reason we switched to iOS 5 only. Can't mix ARC and non-ARC code. And here's another got you. You can no longer create C-style structures that can have objects, because the structure has no way of knowing where the object is and didn't know how to unrelease it. And there's a very slight change in the deallocated method. You don't call your superclass. Yes, in the library, but you can't have it objects that are shared together.
And there's a special way to do that.
Right. Here's some other little things they've implemented new. We now have literals. Just you can create. You always have to be able to create a string by saying quote around the string. It's the same thing as making a call to the string class. But now we have ones for arrays. We have ones for numbers. We have numbers. We have fast enumeration. We used to have to be able to access, in the old days before iOS, to go through an array, you literally had to have a for loop and then say, get index 1, get index 2, which means you had to search the index every time. Apple said this was stupid. Lots of computer science said it was stupid, so they came up with the idea of enumerated objects. But enumerated objects are difficult to work with. People were always screwing them up. So they actually wrote in the language, they say, here's an array. I want every object in the array, just loop through it. Your code gets much tighter that way. Now, blocks are the Objective-C version of lambdas. Does anyone know what lambdas are? Okay, just brand new. We're just starting to use them. We're just starting to love them. They're a wonderful feature for user interfaces. You can say, go ahead, animate this object off the screen, and when you're done, then execute something more. And people are just starting to learn how to do that. Okay, only a couple more and then we'll get to question and answers. I mentioned frameworks, groups of related objects and headers. I double figure if I do that, sorry. The major frameworks you must include are Foundation Class, UI, and Core Data, even if you don't use Core Data. And there are other ones for core animation, for core location, that's the GPS device, and so on and so forth. Each of these frameworks, truthfully, if you're starting out, only learn the first couple frameworks because you'll pick up the other ones as you go along. You pick up frameworks as you look at a cookbook, an example, and you see how you do it. And just remember, if you add these frameworks, you have to add the framework file to the project. Now, the foundation class I mentioned earlier, that was the one that has the basic objects. It's the one that begins with NS. It's universal between Mac and iOS, and very similar to standard libraries. There are a couple design patterns here. A lot of the data objects are mutable and immutable versions. So you have an immutable string, can't change. You have an immutable string, which is a subclass of mutable. Same way in arrays, you get a lot of operations where you get past arrays, and they're immutable arrays, which means you can't change it. Now you can change the object in its content. In other words, if you get past an object, you can make calls to that object or change its variable, but you can't change the array itself. The other major type is data objects. They have strings, dates, variables, values. When you're working with objects, it's kind of nice to have one that's nothing but a number. So they came up with a universal value. The value could be a boolean, a float, an integer. It's just an object you pass around. And then, of course, the standard collections, dictionaries, arrays, and sets. Dictionary is a fancy name for a hash table. Now, Cocoa Touch class, this is the other major thing you're going to have to learn, and we're not going to go into today. This is the user interface. This is what you use with Interface Builder. This is what you use to create views. It's only for iOS. Mac has their own. It uses Model View Controller. Key concepts. Views are the actual objects on the interface. View Controller is the object that you're probably overriding, you're subclassing, that controls that view. Responder, that's where it's a responder chain. You press a button somewhere on the screen. Well, you look at where you're touched, but that thing you touched might not actually respond to it, so it passes it on in the responder chain. This is universal for almost all mobile devices nowadays. These are key concepts you have to understand. Most user interface can be created programmatically by procedure calls. Almost everyone uses the Interface Builder. And I think that's top of the top. I rushed through that, and I hate to have you guys have blank looks. So, if you have any questions in general, please. Yes.
One of the obvious things you pointed out is that we've got to be continuous learning.
Yes.
So far, the books that I have looked at seem to be everything from A to Z. Is there anybody publishing a book that says, well, here's what changed? Just focus on the new things in iOS.
Why do you think we're doing the classes? Yes. There are times when you should know about the underlying structure, like retain counts and counts, in order to understand ARC. But you only really have to work with ARC. There are other things where there are other old ways of doing it, and the books you have show the old ways while there are newer ways. The problem with books is by the time they're published, they're obsolete. So I can't recommend any to us. Take a look at the date on the book. Take a look at the content scanning through. Can't make recommendations from friends and such. It's a lot easier for me to recommend the design pattern book because that's the same for everything. than trying to recommend a cookbook of what the latest stuff is. I'll give you an example. Pragmatic Press is a really good publisher. Addison Wesley is another good publisher. They came out with a core animation. I was one of the beta testers of the book. They released the book, they released the book, went to the printers, and 2 weeks later, Apple released core animation for iOS. And they rushed to the printers and literally stopped a printing press and brought it back and added the 2 chapters, which they had already written, but they weren't allowed to do because iOS hadn't shipped it yet. Put the chapters in, and it cost them a fortune to stop the printing. But that's the problem that happens. As soon as you release it, it became obsolete before it even got in the stores. Other questions?
So like on the iOS developer site, I know like on the Android, I've done stuff with Android, and I know like if you go on their SDK site, like you can't build a huge app, but you can potentially, like they'll go through each component and they'll show you how to build it in their version of Java or whatever. Is there anything?
Lots. I'm sorry. If I gave the impression there isn't, there is. There's tons. There's tons of source code samples. There are tons of I gotta increase my vocabulary, using the same words over and over again. There are many, many example documents, what are not called references, but are called guidelines or explanations. But Apple's, again, has only limited resources. Okay, they're a very small company, relative size-wise, for how much money they produce. And lots of times, core data is a good example, core animation. Pragmatic Press came out with 2 books on those subjects just because the documentation was very good. So yes, check there first. What else? Hopefully I gave you a taste of Objective-C and why they designed it this way and the structure that they use for it. Did I miss anything? Yes, sir.
You have to use Objectives. Can you just use raw C to program on iOS?
You can use generic C for any procedures, but you have to use Objective-C for the user interface. Let's talk about that for a second. Unity. Who's familiar with Unity? C++, right? Because they provide the entire library that does all the user interface to display stuff, and then the C++ implements the Unity calls, which then did probably OpenGL. Okay, I have written code where it was written C++ for the number crunching or for the intelligence or the AI, and then moved it over to, actually I did it for the Mac and the Windows. 2 identical programs on Mac and Windows where the underlying code was C and C++. But if you're actually dealing with the data being saved or you're dealing with the user interface, you got to do this. And that's the same for Android. That's the same for Windows 8. Now, up until very recently, you couldn't program any other language. That was written in code. Apple has since switched that and said other languages, as long as you compile or interpret on the machine. They do not want you to download source code because that's a Trojan horse from another different service.
So can you say that again?
Okay, recent change from Apple. You can download source code and interpret it on the fly. I'm sorry, I may have said that. You can interpret source code on the fly, either compile or interpret it, as long as that code was on the device to begin with from Apple. You cannot download anything from a remote server, because that leaves you open for viruses and Trojan horses. It's just a bad idea.
In other words, if I had like a Python interpreter as part of my
Lua was becoming very popular for some game design. That's a very simple C language, very heavily used in the game industry.
Gotcha.
And there's looking into JavaScript. Yes?
Any advice on code organization, or does Xcode do the...
Xcode does it itself. Every time you want to create an object, you say create object, and here's the super object, and it creates the .h and the .m file for you automatically.
It's already a separate file.
Yeah, already in a separate file. It takes care of it. Now, you can actually override the templates, which I do, because I want ones that have certain things, certain pre-done headers and pre-done comments and everything. It's fairly easy to do. But you can actually create your own template files. So now, if you create a NS view from a template, it not only creates the view.h but m file, but also the user interface file to go with it. So it's a very intelligent template creator. You should never create those files yourself. You should use the built-in. Well, we got 5 more minutes. If you want to walk to another building, or stick around for Duncan's talk on getting it in the store, which, in my opinion, will probably drive you more crazy than writing the application.
Yes.
Would you agree with that? Well, okay, let me rephrase that. Would you agree for a new user, getting it in the store is going to be more crazy than programming it? Once you get the hang of it. Oh, God, yeah. Yeah.
I thought they were just making it difficult on purpose. Trying to keep people that didn't know they were doing it.
Yeah, 2 or 3 years ago it was worse. Xcode handles a lot of the problems you have for now, so it's much easier. That's why I said the Apple keeps changing the stuff, and that's the good news. And the bad news is Apple keeps changing the stuff.